It's time to center mental health in Omaha. At Community Alliance, we're building a new center at 72nd and Mercy Road so that anyone seeking help for their mental health can access the personalized care they need to flourish. Support our campaign at mentalhealthomaha.org.
We can stop HIV, Iowa.
Getting tested for HIV and knowing your status is key.
The CDC recommends everyone get tested for HIV at least once in their lifetime, or more often when needed.
Visit stopHIViowa.org.
This is SpaceTime, Series 23, Episode 74, full broadcast on the 20th of July 2020. Coming up on SpaceTime, mysterious objects discovered in deep space, construction about to begin on the world's largest telescope, the Square Kilometre Array, and NEOWISE puts on a spectacular cometary sky show. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered something new lurking out in the depths of space. It's a series of 4 faint circular radio objects which they've dubbed odd radio circles, or ORCs, which are unlike anything anyone's ever seen before. The findings, reported on the pre-press physics website archive.org, look like distant ring-shaped islands, highly circular and brighter along their edges. Astronomers haven't yet been able to determine exactly how far away these objects are. The only thing they can be sure of is that they were detected away from the direction of the Milky Way's galactic plane, and each appears to be about an arc-minute across. The study's authors have already ruled out some likely suspects, such as supernovae, star-forming galaxies, planetary nebulae, and gravitational lensing events. Among those still in the running are shock waves left over from some extragalactic event, or possibly activity from a distant radio galaxy. Now, all 4 of these objects are extremely bright in radio wavelengths, but virtually invisible in all higher wavelengths, such as infrared, visible light, and X-rays. Interestingly, however, 2 of these objects do have visible light galaxies at their centres, and that suggests there may be some sort of association with these galaxies. Perhaps they were formed by them. Also, 2 of these strange objects were found near each other, and that raises the possibility that their origins could be linked. Astronomers discovered 3 of these mysterious objects during the EMU, or Evolutionary Map of the Universe survey, which is being conducted on ASCAP, the Australian Square Kilometre Array Pathfinder radio telescope located in outback Western Australia. The 4th was discovered by the giant meter wave radio telescope in India, and the fact that it was found by a different instrument helps astronomers confirm that these objects are in fact real and not some unusual artefact or anomaly caused by issues with ASCAP's 36 parabolic dish array. For now at least, the mystery continues. This is SpaceTime. Still to come, construction about to begin on the Square Kilometre Array. And if you're listening in the Northern Hemisphere and you haven't checked it out yet, you really should go outside and scope out Comet NEOWISE. All that and more still to come on SpaceTime. Well, it looks like construction is finally about to begin on what will be the world's largest radio telescope, the gigantic Square Kilometre Array project. The move into building phase follows 7 years of design and prototyping work by scientists and engineers from around the world. More than €1.87 billion will be spent on the mega project over the next 10 years. Headquartered at the Jodrell Bank Observatory near Manchester in England, the project will use 2 networks of hundreds of dishes and thousands of antennas distributed over hundreds of kilometres of the Western Australian outback and the South African Karoo. The Square Kilometre Array will explore the entire history and evolution of the universe, in the process uncovering new and, as yet, still unimagined fundamental physics. Its sheer size and range of operating frequencies will make this observatory at least 50 times more sensitive than any other radio telescope instrument in the world. Two of the world's biggest and fastest supercomputers have been built to process the unprecedented amounts of data expected to be produced by the observatory. In fact, some 600 petabytes of data is expected to be stored and distributed worldwide to the science community every year. That's enough to fill more than 500,000 top-end laptops. The Australian portion of the SKA will contain the low-frequency telescopes and include phased arrays comprising some 130,000 dipole antennas covering the 50 to 350 MHz frequency range. They'll be grouped in 100-metre diameter tiles, each containing about 90 elements, together with their associated electronics. It'll be spread over thousands of square kilometres at the CSIRO Murchison Radio Astronomy Observatory in Western Australia, located some 800 kilometres northeast of Perth. The observatory already has two main operational instruments. There's the Australian Square Kilometre Array Pathfinder, or ASCAP, which uses 36 identical 12-metre parabolic dishes working together as a single instrument to provide fast survey speed and high sensitivity. Then there's the Murchison Wide Field Array of 80 300 MHz low-frequency, fully cross-correlating single dipoles on 128 phased tiles, each comprising 16 dipoles. A third separate instrument at the facility is EDGES, the experiment to detect the global EOR signature antenna and low-noise amplifier radio telescope. It's designed to detect the 21-centimetre redshifted hydrogen line from the cosmic dawn and the epoch of reionization, which corresponds to a redshift of 27. Meanwhile, the South African portion of the SKA will house the mid-frequency array. It'll include several thousand 12-metre diameter parabolic dish antennas, each equipped with a small multi-beam phased array feed and a large field of view covering the 350 MHz to 4 GHz frequency range. Already on site is the South African precursor facility known as Meerkat. It includes an array of 64 13.5 metre dishes covering the 580 MHz to 14 GHz range, plus the 7-dish Cat7 engineering and science testbed instrument. The International Centre for Radio Astronomy Research, Curtin University SKA leader Professor Stephen Tingay, says preparatory work has been accelerating over the past 2 years as key technical milestones are reached.
Typically in astrophysics, you get the full picture when you can observe the same part of the sky or the same object in multiple different wavelengths. But having said that, there are some very, very special things about radio waves. One really nice property is that your telescopes can operate 24 hours a day, 7 days a week. So daytime, nighttime don't affect the radio waves. The atmosphere doesn't affect the radio waves. So you can operate the telescopes all the time. That's one thing. The other thing is that there are some physical processes that are really important in the universe that specifically produce radio waves. So, for example, the most abundant element in the universe, hydrogen, which is one proton and one electron, produces radio waves at a very, very specific frequency, like 1.42 gigahertz. So if you want to trace all of the hydrogen in the universe and use it as a probe for environment and also how the universe is evolving, you need to do that with radio telescopes to detect those radio waves.
Is that what they call the 21-centimetre band?
That's right. The 1.42 gigahertz frequency corresponds to a wavelength of 21 centimetres.
There's ASCAP and there's the Murchison Wide Field Array. How do they fit in with this project?
So the SKA is such an undertaking that it's orders of magnitude more complicated than previous radio telescopes. You basically don't get there in one step. So before getting to the SKA, global community decided to produce a small number of precursor telescopes that were sort of stepping stones to the SKA. So there are 4 of these, 2 in South Africa and 2 in Australia. In Australia, we have the Australian SKA Pathfinder, which has been built and operated by CSIRO. And we have the Murchison Wide Field Array, which is a low-frequency telescope, so a direct precursor for the SKA, and that's operated by Curtin University on behalf of an international consortium of 21 organisations in 6 countries.
Now, when you look at something like ASCAP, it looks like the sort of thing you'd expect with a radio telescope, a whole bunch of big parabolic dishes. I think there are 36 of them, 12-metre dishes, all pointing towards the sky. When you look at the MWA, the Murchison Wide Field Array, this looks like a paddock full of dipole antennas, the sort of things you'd maybe use to watch TV with, but lots of them.
Yeah, no, that's spot on. So the dishes, the sort of satellite dish style technology, if you like, is well suited to those higher frequencies. So ASCAP operates sort of a gigahertz to 2 gigahertz, and so the dish technology works well there. At the lower frequencies, you can get away with a much, much simpler type of antenna. So what you've described for the NWA is spot on. These are antennas that look a little bit like a TV antenna that someone might have on their roof. So it means you can produce a lot of these antennas very cheaply. They also simply sit on the ground. They don't move. There are no moving parts. And all of the operation of where it's pointing and when is all controlled electronically. So there's no big structures to move around, point it to different parts of the sky. So it means they're incredibly cost-effective instruments and really cost-effective to maintain, which means that you can build a lot of them. That's what makes the SKA possible.
And you've been looking at different styles with these too, haven't you? I've seen ones that look like Christmas trees and designs for ones at least that look more like hula hoops and things like that.
That's right. There are lots of different antenna designs that work well at low frequencies, and many of these antenna designs have been fundamentally known for decades. Each of them have different properties, different responses to the sky, different frequency ranges. So it's a matter of finding a balance between the performance characteristics you want from an antenna balanced up against the cost to produce them, basically. So there's a bit of an optimization between performance and cost. So we've been exploring several different antenna types to look at those trade-offs. Are you going to be using just the one type, or will you use some panels with Christmas trees, others with stars? How will it work? Yeah, it's generally not a good idea to your antenna types, because we're going to have to understand the performance of the instrument at a very, very stringent level. So understanding the electronic performance, understanding its stability, understanding its response to the sky. And anytime you mix two things together, you not only need to understand them individually at that level, but you need to understand their combination at that level as well, which is pretty complicated. So we'll be sticking to a single type of antenna in the end. Have you decided which one yet? It's the current reference design, as we call it, is the Christmas tree style of antennas, which is much bigger than the MWA antennas. They're more expensive, but it has a more extended frequency range at the top end of the frequency band. So there are some pros and cons there, but that's the current choice. And there'll be some 130,000 of them. That's right. So 130,000 individual antennas. Those antennas will be grouped up into what we call stations. So each station will have about 256 antennas, and there'll be of order 500 of those stations scattered out across the Murchison over several thousand square kilometres. I take it the Murchison was chosen because it's a radio quiet area. That's right. The Shire of Murchison is Australia's only shire without a gazetted town. It has a population of around about 100 people, and it has a land area equivalent to the Netherlands. So it's very sparsely populated, which means that it's radio quiet. So any TV, FM, any form of electronics, cell phones, things like that. Yeah, so all of those signals vastly swamp the really weak signals that we're seeking to collect from the universe. So the first thing we do is build our radio telescopes as far away from people as possible, but just being mindful that we need to connect to power, we need very high-speed communications, and we need a level of infrastructure and people nearby to support the instrument. And that high-speed communications is important because you've got to literally send, I was going to say buckets, but it's more than that. It's like stormwater drains full of information through pipes to supercomputers in Perth so that the whole thing can be crunched and you can work out what you need and what you don't need. Yeah, that's right. And that's one of the significant challenges for the SKA is that in raw form, the telescope will produce just unimaginable amounts of data per day. That will at some level be processed and the data volume reduced at the telescope in situ. Then the data that need to come from the telescope down to Perth in the first instance to be stored in supercomputing centres, even after it's further processed and reduced in volume, is still going to amount to around about an exabyte of data per year that needs to be stored and utilised for the final science. So an exabyte is 1,000 petabytes and a petabyte is 1,000 terabytes. So if you've got a pretty decent fairly new computer at home, you might have 1 terabyte on board. So an exabyte is 1 million of those, and we collect that every year.
There's also going to be the stuff coming from South Africa as well. You say they've got 2 fields set up there as well with precursors. Tell me about them.
So one of the precursors is called HERA, and it's in some ways a little bit similar to the MWA. It has quite similar scientific goals, although a bit narrower than the MWA. The MWA is a really multi-purpose instrument, but HERA operates at the same sorts of frequencies as the MWA and has the same sorts of science goals. And the other precursor is called MeerKAT.
Yeah, who can forget that name? What a great name.
Yeah, no, exactly. It all fits together nicely. And so MeerKAT, again, is based on the satellite dish style technology, similar to ASCAP, operates in a similar frequency range. The interesting thing about MeerKAT is that it will in itself form part of the SKA. So the SKA in South Africa will be an extension to MeerKAT. So that precursor will be encompassed into the final SKA.
Awful lot of these parabolic dishes.
Yeah, so in the first instance, it's around about 200 for the SKA in South Africa.
What are the questions you're hoping to answer using the SKA?
It's a good question. As I sit here, I'm glancing across at my bookshelf where there are 2 volumes called Advancing Astrophysics with the SKA. Each volume's about 5 kilograms. And there's several hundred chapters in those volumes describing several hundred science goals for the SKA. There's a couple of headline areas of science. So with the low-frequency SKA, that is the SKA to be built in Australia, the most high-level, high-impact science that we hope to do is to look back in time about 13 billion years to the period in the universe, roughly speaking, 1 billion years after the Big Bang. And we're going to attempt to watch all of that hydrogen gas that, remember, produces all those radio waves, form into the first stars and the galaxies in the universe.
Reionization.
Yeah, this is the so-called epoch of reionization. In terms of the normal matter produced out of the Big Bang, it was almost exclusively hydrogen gas. And over the course of the first billion years, that gas accreted under gravity and started to form stars and galaxies. As those stars and galaxies ignited, the high-energy photons produced started to then ionize the remaining hydrogen gas around them. And so you sort of get these galaxies and stars blowing up what we call ionization bubbles. As soon as the hydrogen's ionized, it doesn't produce the radio waves anymore. So we can look back using the low-frequency telescope and look for the mixture of the ionized hydrogen and the neutral hydrogen, which does produce the radio waves. And from that, we can map out how the first structures in the universe formed, those stars and galaxies that then went on to produce new generations of stars and ultimately produce life in the universe.
That could give you some clues as to when dark matter came about.
It's entirely possible. So in that story, I was really careful to refer to the normal matter,
the baryonic matter.
The baryonic matter that you and I are made of and we're all familiar with. It turns out that normal matter makes up only about 5% of the universe. So the other 95% is made up of something we call dark energy and something that we call dark matter. So the dark matter has gravity, but the properties of normal matter. And it's one of the big mysteries in physics is what is dark matter and what is dark energy. So in the process of examining how these first stars and galaxies are produced, it's likely that the distribution of dark matter in the universe at that early stage had a big influence. So we hope to be able to shed some light on what dark matter is.
That's Professor Stephen Tingay from the Curtin University node of the International Centre for Radio Astronomy Research. And this is SpaceTime. I'm Stuart Gary. Still to come, a Comet Sky Show spectacular gracing the skies, and later in the science report, human trials of a potential new COVID-19 vaccine have commenced in Queensland. All that and more still to come on SpaceTime.
When you download the Baker's app, you have easy access to savings every day. Get the most out of weekly sales and receive personalized coupons to save on your favorite items, all while earning 1 fuel point for every $1 spent. Baker's makes it easy to save while you shop, whether it's in-store or online, so you get the most value out of every trip, every time. Download the Baker's app now to save big on your next purchase. Baker's, fresh for everyone. Must have a digital account to redeem offers. Restrictions may apply. See site for details.
Well, if you're listening to us from the Northern Hemisphere and you haven't checked it out yet, you really should go outside to scope out Comet NEOWISE. C2020 F3 NEOWISE made its closest approach to the Sun on July the 3rd, swooping just inside the orbit of Mercury. It'll cross Earth's orbit on its way back to the dark outer realms of the solar system by mid-August. It's already providing skywatchers with a spectacular once-in-a-lifetime cometary display, having lit up the early morning skies about an hour before dawn for the past few weeks. NEOWISE is now moving into the evening skies, close to the horizon in the northeast, just after sunset. The spectacular display being put on by this 5-kilometre wide comet is all thanks to its close flyby over the Sun, which heated up and cooked lots of the volatile materials inside the comet, causing them to boil and vaporize, erupting through the icy crust, and creating a huge coma with a spectacular debris trail. Even the crew aboard the International Space Station have enjoyed the spectacle from their orbiting vantage point high above the Earth's atmosphere. And it's the sort of thing anyone in the right part of the world will be able to enjoy. You should be able to see the comet's central core or nucleus with the unaided eye in dark skies. And if you've got access to a small backyard telescope or a good pair of binoculars, you'll get an even better view of the comet's fuzzy coma and its long streaking tail. The comet was discovered by NASA's NEOWISE Near-Earth Object Wide-Field Infrared Survey Explorer spacecraft back on March the 27th, using its 2 infrared channels which are sensitive to the heat signatures given off by the object as the Sun started to turn up the heat. Of course, the people of Sydney and along the New South Wales south and central coasts had their own sky show last weekend, as a meteor streaked across the night sky just in time to make an almost live appearance on local evening television news services. Social media was lit up with images and videos of the celestial sky show, the green-coloured meteor causing quite a commotion as it moved from east to southwest above the city's skyline, leaving a fiery trail. People from as far afield as Cessnock in the Hunter Valley, as well as Bondi Beach in the east, Cronulla in the south and Mossman on the harbour, all reported the spectacle, made even more stunning by lightning from distant thunderstorms. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. Human trials of a potential new COVID-19 vaccine have begun in Queensland. The early-phase clinical trials by the University of Queensland will involve an initial 120 volunteers. More than 4,000 people applied. This initial trial will evaluate the safety and immune response of the vaccine in a group of healthy volunteers. Testing has already shown that this protein-only vaccine was effective in the laboratory, neutralising the virus and proving safe to humans. Preliminary results are expected in about 3 months. If all that goes well, scientists will move on to the next stage in the vaccine's development with a larger trial to see how the vaccine works across a larger population. The clinical batch of the vaccine was manufactured through a close partnership between the University of Queensland and the CSIRO, with technical assistance from the Australian biotech company CSL, formerly the Commonwealth Serum Laboratories, which will manufacture the final product if it's ultimately approved. If all goes well, the vaccine could be available early in the new year. And of course, it's not alone. There are currently some 180 vaccines being developed around the world, including several others right here in Australia. The World Health Organization is under fire from scientists and medical doctors after confirming that it won't visit the Wuhan Institute of Virology as part of its investigation into the cause of the COVID-19 coronavirus. The virus is believed to have leaked from the Class 4 high-security laboratory into the general population. The unusual move is in line with the World Health Organization's staunch support for Beijing, despite mounting independent evidence that the Chinese government covered up vital details of the virus, including its human-to-human transmissibility for several months, while at the same time allowing infected people from Wuhan to continue travelling around the world, yet banning them from travelling to other parts of China. The virus, which has infected more than 14 million people and killed more than 600,000, originated in Wuhan around November last year. Beijing and the World Health Organization didn't admit there was a problem until the end of December. Whistleblower doctors and journalists speaking out about China's actions have either suddenly died, been jailed, or simply disappeared. And Beijing has been imposing stiff sanctions against countries criticizing its behavior. A new study warns that animals will struggle to adapt to the warming effects of climate change. A report in the journal The Proceedings of the Royal Society B looked at some 2,059 separate animal species, finding that it'll be much harder for animals to adapt to the extreme heat than extreme cold in a rapidly warming world. The animals examined included amphibians, reptiles, birds and mammals from a wide variety of different climates, with the researchers finding they were able to evolve tolerances to extreme cold faster than to extreme heat, meaning they may struggle to catch up with our ever-increasing global temperature. A new study has found that hearing could be the last sense to go during the process of dying. The findings, which are published in the journal Scientific Reports, are based on EEGs, which measure electrical activity in the brain, and show that people may still be able to hear while in an unresponsive state at the end of their lives. Scientists analysed data collected from healthy control patients, from hospice patients when they were unconscious, and from the same hospice patients when they become unresponsive. In the final hours before an expected natural death, many people enter a period of unresponsiveness. The data shows that a dying brain can respond to sound even in an unconscious state up to the final hours of life. The findings suggest that those last goodbyes may well provide a comfort for loved ones during their final moments. And it's probably another good reason not to be using the term switch her off to someone on life support. Researchers have come up with a handy guide to conspiratorial thinking inspired by the COVID-19 coronavirus and the Plandemic pseudo-documentary. Tim Mendham from Australian Skeptic says the 7 characteristics listed in the guide really do help identify those suffering from conspiratorial thinking.
Yeah, it is a handy guide, actually. Things to watch out for. You know, it's like if you're talking about coronavirus, do you fever? Do you have a cough? You have trouble breathing? This is actually designed to spot people who believe that coronavirus is a conspiracy. So they have their own little traits that you can look at, various things, especially in response to this pseudo-documentary Plandemic, which is full of conspiracy theories about coronavirus, and which itself has been heavily criticised. But when Plandemic, dare I say it, went viral, it created a lot of response from a lot of people who knew better than the people who are in the documentary really know. They have more expertise. But therefore, they developed, in response to that and general sort of conspiracy theories, a little guide to the issues or the themes you'll find that conspiracy believers always come up. One is contradictory beliefs. They'll believe 2 things at the same time, that coronavirus doesn't exist, it's phony, and that it was created. So you can't have it both ways, but that's something that crops up, and it's quite common in conspiracy theories that people don't mind having 2 different beliefs at the same, 2 or 3 or more beliefs at the same time that are contradictory. The second one is overriding suspicion, which is basically everything's a fake, everything's crooked, you're crooked, you try and criticise me, therefore you're part of the conspiracy. It's everything that there is no such thing as a trustworthy official or expert. So you're off on the wrong foot straight away. You just can't sort of, when you find someone who's saying, yeah, you're part of the conspiracy, this is part of it, that's part of it, and your Uncle Bob's part of it as well, you say, well, yeah, where do you go from here? But that's a common thing. Obviously, there's bad intent on the people who are creating the conspiracy, who are the conspirators. They are trying to run the world. They are trying to sort of put me in jail. They are trying to sort of ruin me professionally. They are trying to sort of control people. They're trying to cut population down. They're trying to control the population, heaven knows what. But there's a very evil intent by the government / business / military / media / whichever sort of slash you want. You can drag in as many people as you like. And that they're all evil and they're all out to do something. And surprisingly, the thing they're out to do is apparently very open, because all the conspiracy theorists talk about them quite openly, so they're not that secret. They know that something is wrong. That's the fourth element, the fourth trait. They know that something is wrong. Sometimes they don't know what it is, but they just have a feeling that something is wrong. So basically it's this feeling of sort of the world is against them, things are unstable, which things often are. Chaos is a part of life. Yeah, something's fishy about this. I just don't understand it, because it's often based on not understanding what a situation is, but then trying to think that you should, and perhaps you shouldn't. There's obviously a victim in this. and it's often the individual, the conspiracy theorists are personally persecuted by them, capital T, them, because they have this special knowledge, which they're sharing everywhere. It's basically, it's making themselves seem more important than they really are, and perhaps that's the ultimate reason for being a conspiracy theorist, is to give yourself a bit of kudos by having special knowledge and stuff that you don't know. They're immune to evidence, and that's what we've discussed before, I know. It doesn't matter how much stuff you can give them that sort of debunks their theories, that they will sort of ignore it, or they'll find a way to rubbish it straight away. But generally, they just won't look at it at all. It's an echo chamber life that they live in, and they will just listen to each other going round and round and round and round and round with the same sort of evidence, in quotes, of conspiracies. And lastly, they reinterpret randomness, and that's what I mentioned before. Chaos is part of life, and things happen. Often you don't know the reason why things happen, but someone says, well, there must be a reason. Maybe there is, maybe there isn't, but that doesn't mean that that's a conspiracy. But therefore, conspiratorial thinkers, people who follow conspiracy theories, will try and find connections, and every connection is evil and sinister, and they will create patterns where there ain't none.
Yeah, George will keep seeing police cars.
Yeah. I mean, it's the classic thing is the man in the moon, right? That's a random pattern where people see a face, right? Actually, I think in Chinese it's a rabbit, and another culture is a man with a wheelbarrow.
It's a jade rabbit.
So I mean, you'll see what you want to see. You see with faces in clouds, that sort of stuff is classic sort of pareidolia, seeing a pattern where none really exists. But this is also about, therefore, beyond just faces and that sort of stuff. It's actually conspiracies and government actions, and you create a very large construction based on these patterns that really sort of these connections between this event and that event and the other event, where there really ain't none. It's a funny old life, actually, conspiracy.
Sometimes a black cat crossing your path simply means it's going somewhere, as Groucho Marx would say.
Yes, that's right. Yeah, it's not necessarily after you.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.